Let's go over 8.4, choosing the sample size for a study. This is the last section of chapter 8. And basically in section 8.4, we're working the formula that we already know backward to find the sample size n. So this one's a little mathy. We're actually solving equation for n. Let me go ahead and start this with you. It's very short though. I think the note is only like front and back of it. All right, so what kind of questions can we answer after this lesson? Something like this maybe. How large an exit poll must be so that a 95% confidence interval for the population voting for a candidate has a margin of error of 0.04. Now remember, the ones that we were working on so far in 8.2 and 8.3, we were trying to find that margin of error, right? We were using the sample size, and we use the sample size to find the standard error and multiply that standard error either by z-score or t-value to find the margin of error, and that's how we created a confidence interval, right? Now this section is just working backward. They're gonna give you how many people should I survey or how many people may I interview in order for me to have my 95% confidence interval to only have a margin of 0.04. Now, the thing is, the margin of error is margin of error, right? We want that to be as small as possible, and that will happen if you take a big sample. But then the thing about taking a big sample, that's gonna be expensive, right? If you send somebody to door to collect survey result, it's taking their time and you have to pay them. So we try to keep the sample size as small as possible, but we don't want to compromise the margin of error. We don't want that margin of error to be too big. So what we can do is, well, this is what we're going to do in this section. The key results for finding the sample size. The margin of error depends on the standard error of the sampling distribution of the point estimate. Oh, it's a very heavy sentence, but let's talk about this. Now, how did you make your confidence interval? You have that point estimate in the middle, right? That's your best guess. And then you added a margin of error or subtracted a margin of error to get that lower limit and the upper limit of the confidence interval. And how we find that margin of error was by finding the corresponding z-score or t-score by the standard error formula. And that standard error, I'm reading the second part now, the standard error itself depends on the sample size. Somewhere in that standard error formula, both for the population mean and for the population proportion, you use that sample size little n. Okay? So, margin of error depends on standard error, and that standard error depends on sample size. So once we specify what kind of margin of error we want and what kind of confidence level we want, we can determine the value of n, how big the sample should be, to have a standard error giving that margin of error with that confidence interval. So basically, what are we saying in this slide? If you decide on the confidence level and margin of error, we should be able to solve for the sample size and decide how many people we should ask the question or how large should an exit poll be. Okay, so let's look at an example one together. A TV network plans to predict the outcome of an election between Levin and Sanchez using an exit poll that randomly samples voters on election day. They want a reasonably accurate estimate of the population proportion that voted for Levin. Of course, we want that estimate to be reasonably accurate. The final poll a week before election day estimated her to be well ahead, 58% to 42%. So, that's telling us Levin is going to probably win, and that was taken a week before the election day. So they do not expect the outcome to be close, like 58% to 42%. I think that's a big difference there. Since their finances for these projects are limited, and that's very common in many projects, they don't want to collect a large sample. A large sample is going to require more time, and you have to pay more people. If they don't need it, they don't really need to create a large sample. But I mean, if you have lots of money and lots of resources, you can make your sample size as big as the population, and it will be very accurate, right? But that's not really true in real life. So they decide to use a sample size They want to get a sample size. Somebody wants to, they want someone to tell them, so how many people should we interview, or should we take the exit poll of? In which the margin of error is 0.04. Now, rather than their usual margin of 0.03. So they're kind of increasing the margin of error. So they know they may be a little wrong. They're increasing the margin of error really a little bit bigger. But why are they doing that? Well, their finance is limited, and they were reasonably. They have a good reason. Like, see, the final poll a week before the election day already told them that this 11 person is going to be well ahead. The outcome's not going to be close. So, okay. So they want to save some money on this by reducing the sample size. Will help them. What is the sample size for which a 95% confidence interval for the population proportion has a margin of error equal to 0.04? Now look at these two things given to us. Confidence interval is 95%. Now remember, for proportion, what is a z-score that goes for 95% confidence level? Remember, that z-score is 1.96. So you'll see that guy very soon. And the margin of error, let's call it m. M equals 0.04 in this case, okay? So, recall that formula. For population proportion, the standard error formula is this one down here. I think I got it on your paper. Highlight this, circle this for me, because what we're going to do is we're going to use this formula down here, and we're going to plug in everything we know, and we will solve for the letter n. Okay, we will solve for the letter n. All right, so here's what we want. What we want is 1.96, and you know where that came from. That's the z-score for 95% confidence level. Okay, 1.96 times standard error to be 0.04. This is the margin of error. We want the margin of error to be 0.04. Okay, so we're gonna set it up. We're gonna solve an equation. We first have to set it up. Set it up as 1.96 times standard error equals 0.04. Okay. Now what you're going to do is plug in that big formula for standard error. And remember this p-hat formula that we used in 8.2. 1.96 times square root of p-hat times 1 minus p-hat divided by n. We want that to be equal to 0.04, right? Now, I'm going to try to solve this for n, and n is in here. I'm going to first get rid of this 1.96. That's multiplying 1.96, so what makes sense? We're going to divide both sides by 1.96. And you know you can divide 0.04 by 1.96, but that came out to be like a nasty looking decimal. So I'm just going to keep it as 0.04 over 1.96. Now real quick though, as you are solving an equation, if you have one equation, we better have one unknown variable. Unfortunately, I don't have that here right there, right? I don't know what n is, that's what I want to solve for, but we better know what p-hat is, right? And remember, p-hat stands for sample proportion. They gave it to us in words. They gave it to us in words. Remember that exit poll a week before the final election day? They said Levin was ahead, what? With like 58% to 42%. So p-hat, since the latest poll before election day predicted that 58% of the voters preferred Levin, it is sensible to substitute 0.58 for p-hat in this equation. So p-hat, the sample proportion, we're going to go ahead and use 0.58. Okay? Now plug that in. And after that, to get rid of the square root, how do you get rid of square root? You square both sides, okay? If you square both sides, the left side will just come out as a fraction, and the right side is 0.04 over 1.96, that getting squared. Now, I want to solve for n, but since n is stuck in the bottom of the fraction, I'm going to temporarily rescue this n by multiplying both sides by n. If I do that, the left side comes out to be just the original numerator, 0.58 times 1 minus 0.58, and the right side is 0.04 over 1.96 squared times n. Now, if you want n by itself, we're almost done. We're one step away. N is getting multiplied by this square, right? So the only thing that you have to do to both sides is divide both sides by this thing that n was getting multiplied by. So it looks a little nasty, but your n, the sample size, is going to be 0.58 times 1 minus 0.58 divided by this term. And if you put that in your calculator, you will get 584.88. Now, you cannot sample a decimal number of people. So, to guarantee this, we're going to just round up, okay? So, let's go ahead and take a random sample of size about n equals 585 people, and that should give a margin of error of about 0.04 for a 95% confidence interval for the population proportion. So like I said, this one is a little mathy because you have to solve it backward. But here's the thing. I mean, this has a formula. Just like, it's going to be the same all the time. So I'm going to go ahead and, well, before I do that, yeah, let's look at this one more time. Now, notice we use what? 0.58 for the p hat in this equation, right? And we used 0.58 because that was reasonable to kind of believe that the sample proportion will have 0.58 because that result was a week before. But what if we didn't have that number? What if we don't know p hat? What can we do? And in a couple of cases, some of these examples that we're going to see, or problems that we're going to see, they're not going to give you the p hat. And if that happens, I have a suggestion, okay? If they don't give you p hat, you'll do the same thing. But if they don't give you p hat, then just plug in p hat equals half. We're just going to go for half and half. Like, we have no idea, so we're just going to assume half of them will. Okay, so 0.5 is the general number. If you don't know anything about the p hat, you're going to plug in 0.5, okay? All right, do the same math. Do the same math. It's exactly the same thing as before, but we're just using 0.5 instead of 0.58. And that kind of gives you a sample size that is slightly bigger. If you don't have any idea about the sample proportion, then we're not going to do such a great job of guessing the population proportion. So of course, if you don't know any, if you have no idea about the sample proportion, we're going to have a bigger error, bigger margin of error. Therefore, we may have to go for a bigger sample size. So if you don't know the p hat value, then we're going to probably have to sample about 601 people compared to, what was the other number? 585 people. If you knew a little bit about the population proportion by looking at the sample proportion. But if you don't know p hat, what number should you use? 0.5 to be safe, okay? All right, now you don't have to solve for it every time. So here is the formula I'll give you. So anytime you got a sample size problem, they're asking you, hey, how many people should I survey? How many, what should be my sample size? Given, but they better give you the same, the margin of error they want, and they also need to give you the confidence level. If they give you 95% confidence interval level, then your z will be 1.96. But if they give you 99%, the z-score will be different. But for 95%, z is going to be 1.96. So once we solve for it together on example 1, we can go ahead and just use this formula to solve for n. This is the step that you're going to take. But you kind of remember or recognize the format, right? All right, let's do another example. The election is expected to be close. Close. So we're going to have like 50%, 50%, huh? Pollsters planning on exit poll decide that a disk is almost full. Probably all these videos that I started recording lately. All right. An exit poll decide that a margin of error of 0.04 is too large. Okay. So you know what they want now? They want us to make that margin of error smaller. How large should the sample size be for the margin of error of a 95% confidence interval to equal 0.02? Look what they're doing. They want the margin of error to be half. Okay, they're asking a lot, but you know what? We'll do the math and we'll find them the sample size, okay? So what if they want to cut down that margin of error from 0.04 to 0.02? As you know, we better go up on the sample size. If they want more accurate result, then they better pay for it. So they're going to have to probably sample more people, spending more time, right? So let's see. Since the election is expected to be close, we can expect p hat to be near 0.5. So 50%, 50%. That sounds like a good number to use. The formula, please change that to in the formula. In the formula, we set p hat equals 0.5 to be safe. We also set the margin of error, m, to be 0.02 and use z equals 1.96 because I still want that 95% confidence interval. So you plug in these inputs, you plug in these p hat equal 0.5, m equals 0.02, and z equals 1.6 into that blue formula that we just shared, which is in your notes, and then do the math. We plug in these into our formula. Then you're going to get, look at that sample size. The sample size, when they wanted to decrease the margin of error from 0.04 down to 0.02, the sample size increased up to 2,401 people. So the sample size of about 2,400 people is approximately 4 times the sample size of 600. And you remember that 600, that was when they wanted the margin of error to be 0.04. But if they want the margin of error to be half, they're going to have to sample 2,400 people. The new sample size of 2,400 is necessary to guarantee a margin of error of 0.0. No, change that to 2 for me. That 2,400 is the required sample size to guarantee a margin of m equals 0.02. M equals 0.04 was gonna be for the sample size of 600. Reducing the margin of error by a factor of 1/2, guess what happened? It required us to quadruple the sample size n. 6 times 4, 600 times 4 is 2,400. So it's a great idea for us to get a smaller margin of error, but you also have to think about the cost in order to do that. So you know what? I'm not going to go over. There's some fun reading for you. Now I'm gonna come back and do this, but what I kind of talked about. I want you to read 2 extra pages. It's optional. I'm not gonna really put it on an exam or anything, but there are other factors that affect the choice of a sample size, like cost. And what will happen if you use small n, if you're really trying to save and use a small sample size? And what kind of things will happen for the confidence interval for a proportion with small sample size? There's 3 small topics that you can read about in your textbook 370 to 372. I'm not going to go over them, but just kind of assign it as additional reading pages for you. And you do all have access to your ebook on My Labs, okay? So if you never opened your book before on this, it's definitely interesting pages to read about. Now let me go back and look at one more example, because look, the 2 examples, actually more like 3 examples that we just talked about, were all about estimating population proportion, right? But what if you want to do the same exact process for population mean? I mean, we can solve for it, but you see the process of solving for n is very similar for population mean too. So I'm going to give you the formula here. If you want to find the required sample size n, this is what you're going to do. You're going to square the standard deviation, multiply that by the square of the z-score, and you will divide by the square of the margin of error. And now we can talk about how this formula came about, but this is really just simply solving the standard error formula for n, okay? Not only the standard error formula, the margin of error formula for n, okay? Alrighty, so let's look at the very last example. A social scientist studied adult South Africans living in townships on the outskirts of Cape Town to investigate educational attainment in the blank community. In a blank community? No, that was a black community. Why did I do that? Black community, thank you. Educational attainment is the number of years of education completed. Many of the study's potential subjects were forced to leave Cape Town in 1966 when the government passed a law forbidding blacks to live in their inner cities. Oh my goodness. Under the apartheid system, black South African children were not required to attend school, So if they're not going to require children to attend school, they're not going to go to school. What else? So some residents had very little education. Okay. Okay, now let's keep going. So what's the question? How large a sample size is needed so that a 95% confidence interval for the mean number of years of attained education has a margin of error equal to 1 year? Okay, so they're doing some kind of social science study, and this is the question that we should answer for them as statisticians. Okay, we can do this because we know how to find that. So they're about to go out and collect some sample or collect some answers from these people, and they wonder, how many people should I survey? 50? 100,000? 500? We're gonna tell them. They said 95% confidence interval, so we know that the. Now here's the thing though. Do we know? Because remember, when did we use t-value instead of the z-value? Remember, for confidence interval for population mean, sometimes you have to look up this t number, right? And we had to use those t numbers if we had no idea about population standard deviation, right? Now, they don't even have a sample yet. So I can't use sample standard deviation to create this margin of error formula. So what we're going to have to do is, let's do our best and guess. Let's do our best and guess the population standard deviation of educational attainment in this population, okay? Because think about it. What's the minimum number of years of education? 0, right? Someone may get 0 years of education. So minimum will be 0, right? It can't be negative, but how high can it be? Usually, K-12 system, it goes up to 12, but some people may go to college, so maybe like 16. Some may go to grad school, so maybe 18. Some may go to like law school or what else, like medical school, maybe bigger. But let's talk about that population standard deviation in this slide. No prior information is stated about the standard deviation of educational attainment for the township resident. As a crude approximation, we're just going to make a wild guess. We might guess that the education values fall within a range of about 18 years. Okay, such as between 0 years for somebody who never went to school to 18 years. Like, why 18 years? Because if you graduate from high school, you already got 12 years of education. And maybe if you consider preschool and kindergarten before that, maybe more. But you go to college and maybe you go to graduate school. Okay, it's reasonable to kind of have a crude approximation that the range is going to be from 0 to 18 years. Okay, now, we're going to assume that the distribution is bell-shaped and the range from 3 standard deviation down to 3 standard deviation above. If you add them together, mu minus 3 standard deviation to mu plus 3 standard deviation, that's 3 to the right and 3 to the left, right? So we're going to have equal 6 standard deviation pieces, right? And if the range is 18, I can divide 18 by 6. So what we're kind of guessing is the standard deviation is going to be approximately 3 years, assuming that a normal distribution fits here, and that in a normal distribution, about 99.7% of the data are within positive or negative standard deviation away from the mean. So it's kind of cool how we are just having a crude approximation of what population standard deviation is for this group. We're assuming, we're kind of thinking that the standard deviation is approximately 3. Okay, so we'll go ahead and use that number. We want the desired margin of error to be 1 year, right? They gave that to us. They want that margin of error of 1. Now, so we plug in that sample size formula into the sample size formula. We're going to use the standard deviation to be 3, kind of assuming that education attainment goes from 0 year to 18 years. And then we're going to use 1.96 for the z-score, since it's 95% confidence interval. And then the margin of error, the desired margin of error is 1 year. So the denominator will become 1 squared. Okay, now in this video, I never talked about how they came up with that formula. We can come up with that formula using the margin of error formula for population mean, and then just solving it backward. But since it was on your textbook, I'm just going to go ahead and give that to you, and then we can use it. If you plug that in, look at that sample size. We really don't need a huge sample size. We just need to survey about 35 people to guarantee a margin of error of just 1 year. So we need to sample randomly, the key is randomly though, randomly about 35 subjects for a 95% confidence interval for mean educational attainment to have a margin of error of 1 year. Now this is a powerful stuff, guys. Because look, how many people are in our population? We're looking at what? People in Black South Africans in Cape Town? We're trying to come up with a confidence interval that will capture the educational attainment, the number of education, the average number of educations they got. And in order for us to do that with 95% confidence, with only 1 year margin of error for the standard the margin of error, how many people do I need to survey? Just 35. Now, this is good. This is good. So this makes very much sense how we have to think about sample size, because realistically, when you are designing a study, you already know what kind of confidence level you want, and you kind of already know you don't want your margin of error to be too big. But you may have to compromise on your sample size. You may have to, because if the sample size comes out to be, oh, you have to survey 2,000 people, and you don't have time to do that, maybe you have to go a little bit bigger on your margin of error. But that's it for 8.4. You can read the textbook section, like those 3 sections that I kind of just mentioned earlier, to learn more about the other factors that affect the choice of the sample size, what happens if you use small n, small sample size, and the confidence interval for a proportion with small sample size. But that's it for chapter 8. I think I covered everything that I wanted to in chapter 8. We talked about statistical inference, the first method of creating confidence interval. In chapter 9, this Friday, we're going to talk about hypothesis testing, and that's going to take us a week to cover, but go and try your homework, and please email me when you get stuck on your homework problem, all right?